Okay, so today we are just going to do the two practice problems for the third lesson, the putting it all together. Basically, we're going to be given a word equation, and then we're going to transfer it to a formula equation, and then we'll balance it. So that's all we're doing today. We're going to do two examples. So let's get started. So we're first going to look at this magnesium chlorate. So it's obviously not an element, it's a compound, and since magnesium is a metal, it's an ionic compound. So I like to write the charges up here. So magnesium, the periodic table, has a +2 charge, this whole group does. So Mg +2, and then chlorate. So you might be tempted to try to grab this right here as chlorate, but this is actually chloride. So chlorate is on our, what is this, polyatomic ions chart. Right here is chlorate, so it's ClO3 with a -1 charge. So ClO3 with a -1 charge. And then all you would have to do is bring these charges down, and you have your formula. So that would be Mg1, but we don't put the 1. So Mg ClO3 2. We bring our arrow over, and then we're looking at our next set of, or whatever, we're looking at our next section of this chemical equation. This is not an element, it is a compound, and it is magnesium chloride. So since this is a metal, we're going to consider this an ionic compound. Magnesium, it's an ionic compound because of the metal, so magnesium is a +2 charge. Chloride is a -1 charge, so this is chloride right here, okay? -1, and then we just do the cross method, and we will have Mg1, but we don't write it, Cl2. And then our plus sign over here. Oxygen is an element, it is diatomic, so we will call it O2. Okay, and now all that's left is balancing, so we'll do the tally method. I told you yesterday to make sure that you can, if you want, when you do the tally method, you can keep the polyatomic ions together. However, I did tell you that some of them will separate, so this obviously is our first example of it separating. So we do have to separate that chlorine and oxygen. So we will write magnesium, chlorine, and oxygen. We have one magnesium here, one here. We have two chlorines here. Sorry, I'm sure y'all were yelling at the screen. Two chlorines on this side, two chlorines on this side. And then we have two oxygens here. And, oh, this is annoying. We have 6 here. So we now need to change this one. If we multiply 2 by 3, we will get 6 oxygens. And that's balanced. So 1 magnesium on each side, 2 chlorines on each side, and 6 oxygens on each side, and we are good. Okay, let's do our last example. This example includes polyatomic ions as well, and it includes elements where we will have a Roman numeral, so this has everything. So this is not an element, this is a compound, potassium carbonate. Potassium is a metal, so we are going to consider it an ionic compound. So potassium, according to the periodic table, has a +1 charge. Carbonate, this is carbon, it's not carbide. This is not carbonate, so don't come and grab this on the periodic table. Carbonate is here on the periodic table, so CO3 with a -2 charge. Okay, and then you will just bring down the charges like this, and your compound will be K2 CO3. Bring down your plus sign, and then we're going to do the same. Okay, so we have chromium with a +3 charge. Chromium, this is a metal, this is a metal, this is a metal. So chromium will have a +3 charge, so C. We know it's a +3 charge because of the Roman numeral. And nitrate. So remember, don't grab it from here. This is nitride. Nitrate is going to be taken off the periodic table. Nitrate is right here. So it's NO3 minus 1 charge. Okay, so we're going to cross our charges down, and we will end up with CR1, but we don't write it, NO3, 3. And don't forget your yield sign. Okay, now we will go on to this one, potassium, and you can just look over here. Potassium has a +1 charge, nitrate, NO3, minus 1 charge. Once you cross them down, it's a 1:1 ratio, so it doesn't matter. So we're just going to write KNO3. Okay, chromium. Cr +3. And carbonate, CO3 with a -2 charge. So we're going to bring those here and here. And it will be CR2, CO3, 3. Okay. So yeah, now we need to balance it, right? So we'll do the tally method for all of this. And if this is where it comes in handy, where you can keep these the same, we have carbonate on both sides. We have nitrate, so we are okay. We'll keep them all. So we have Cr, and we have potassium, we have carbonate, and we have nitrate. Okay, so chromium, we have 1 chromium on this side, we have 2 on this side. So already we need to write a 2 here. Calcium. Potassium, we have 2 on this side, 1 on this side. So we need to add a 2. Okay. Carbonate, we have 1 on this side, but we have 3 on this side. So we need 3 here, which does mess up something. We have good carbonate here, however, we have messed up our potassium, and now we have 6 potassium, okay, here. So we need to change this. We need 6 of them. So to make this 6, we need to change this to 6. So we have 2 chromiums, 2 and 2. We have 6 potassiums, 6 potassiums. Carbonate, we have 3 carbonates and 3 carbonates. And nitrates, we have 6 nitrates and 6 nitrates. So everything checks out.